given the function x squared times y squared equals 9, we want to find the equation of the tangent line and the normal line at the point -1, 3. All right, so I do have that image here of the graph. Let's put it over here. So this is the graph of x squared y squared is equal to 9. Okay, and what we want to do is, here's the point -1, 3. We want to find the equation of the tangent line, right? So the tangent line, okay, going to look a little something like this over here. Okay, the normal line is perpendicular to the tangent line here. Okay. Well, we know that, well, tangent lines, right, derivatives, right? We want to find the derivative of this. Well, in this case, we're going to have to use implicit differentiation, right? Because we don't necessarily want to solve for y. Okay, so we can use an implicit differentiation, but in this case, we do have to use the product rule as well. Okay, so remember, if you have fg, right, a product of a function which is two terms multiplied together, then the derivative is going to be f prime g plus g prime f. Okay, and of course, the main thing to remember here with implicit differentiation, whenever we take the derivative with respect to y, we need to make sure we multiply by dy dx. Okay, so what is the derivative of this guy going to be? Okay, remember what we're doing is we are finding d dx of x squared y squared, and we are finding d dx of just the number 9, right? Of course, that's just equal to 0. So we're going to use a product rule on this guy. So what do we get? Well, derivative of x squared is 2x, so that's 2x times y squared, plus the derivative of y squared is 2y dy dx, right, and still times that x squared there. Okay, and this is just going to equal, well, the derivative number, right, that's just equal to 0. So what happens when we solve this? We'll subtract this to the other side. So 2yx squared dy dx equals negative 2xy squared. So we'll just bring that over. Dy dx equals negative 2xy squared over 2yx squared. And we do see that some terms do cancel out, right? One of the y's will cancel out here. That x will cancel out with one of those x's. So notice what we're left with. We are left with negative y over x. This is the derivative. Okay? So at this point then, right, we notice that the x value is -1, the y value is 3, right? So then the slope, right, the slope at -1, 3, right? Well, we just plug in the y value here, the x value here, we notice we get -3 over -1, which is just 3. So if you draw a line here, right, if you draw a line here, the slope of that line is going to be 3. Then how do we get the equation of that line? Well, we just use the Poincare formula, right? Y minus y1 equals mx minus x1. Okay? And of course, just using that point. So y minus 3 equals 3 times x plus 1. Right? We'll distribute through here, add the 3 over, y equals 3x plus 3, and then plus this 3 as well, we get plus 6, right? So that is going to be the equation of that tangent line here, right? It'll go through the point 6, has a slope of 3. Okay? I guess we can draw that as best as we can, right? There is a tangent line. Okay. What's the normal line? The normal line is perpendicular to the tangent line. Okay? So it's the same point, right? It's the same point, -1, 3. But wait a minute. What do we know about the slopes of perpendicular lines, right? They are negative reciprocal. So if the slope of this black line, right, the slope of the tangent line here is 3, what is the slope of the normal line going to be, right? It's called normal or orthogonal, right? The negative reciprocal, -1/3. Okay. So to write the equation of the normal line, which is this green line here, we'll just use this slope and of course the same point. So y minus 3 equals -1/3 x plus 1. Right. In this case, I'll just go ahead. I have a little bit of space here, so I'll write it out. Then I just add the 3 back at the very end. So y equals -1/3 x plus, and then we add 3 to that, we get 8/3. Okay, so this will be the equation of the normal line.